A balanced chemical equation happens when the number of different atoms of elements on the reactant side is equal to the number of atoms on the product side. So the equation has the same number of each type of atom on both sides. Now in this video, I'm going to show you two approaches in balancing chemical equations. First is the traditional balancing method, and second is the algebraic balancing method. Let's start with the traditional method. The traditional method involves trial and error. For example, hydrogen reacts with oxygen to yield or form water. The first step is to count the number of each type of atom on each side of the equation. So here, in the reactant side, I have two hydrogen atoms and two oxygen atoms. It's here. In the product side, I have two hydrogen atoms and one oxygen atom. Now, it is important to note that whatever is done here must reflect in your equation. Okay? Now, as you can see, the number of hydrogen atoms are balanced, 2, 2. But the oxygen atoms are not. So the second step is to multiply coefficients to make the number balanced. So I will multiply 2 here. Now again, this one must reflect in the chemical equation, so I will write 2 in front. Now by doing this, this coefficient will be multiplied to the number of hydrogen. Okay, so we will have 2 times 2 equals 4 hydrogen atoms in the product side. Now the number of hydrogen is not balanced. Okay, I have 2 here and 4 here. So what I will do next is to multiply 2 in the product side to get 4 hydrogen atoms and write 2 here as well. Now let's check. I have 4 hydrogen atoms, 4. I have 2 here and 2 here. So we can say that the equation is balanced. Let's have another one. This equation is read as nitrogen reacts with hydrogen to yield ammonia. So the first step is to count the number of each atoms on each side. So I have here 2 nitrogen and 2 hydrogen atoms. Here I have 1 and here I have 3. As you can see, this is unbalanced. So what I will do is to multiply 2 here to get 2 nitrogen atoms. So this one will be multiplied here. I will have 6 hydrogen atoms. Now to make these hydrogen atoms balanced, so what I will do is to multiply 3 here to get 6. Now the equation is balanced. 6, 6, 2, 2. Now let's talk about algebraic method. This method of balancing chemical equations involves assigning variables like A, B, C as stoichiometric coefficients to each species. Now let's consider the reaction between glucose and oxygen that yield carbon dioxide and water. So one look, you already know that this is unbalanced. I have 6 carbon atoms here and I only have 1 here. The first step is to assign variables. I will assign A here, B in the second reactant, C in the first product, and D to the second product. The second step is to formulate equations for each atoms. I have 3 atoms, so I will have 3 equations. Let's start with carbon. In A, I have 6 carbon, so I will write 6A. In B, I don't have carbon, so I won't write anything. Now this arrow sign will become equal sign. In C, I have 1 carbon atom, so I will write C. In D, I don't have any carbon atom, so I won't write anything. Now let's go to hydrogen. In A, I have 12 hydrogen atoms, so I will write 12A. In B, I don't have, so no B. Equal sign. In C, no hydrogen. And in D, I have 2. So I will write 2D. Now in oxygen, I have 6 oxygen atoms here. So 6A plus 2B equal sign. In C, I have 2 as well. So I will write 2C plus in D, I have 1. Okay. Now the next step is to let one variable equal to 1. Okay. Doesn't matter which one you choose, just let one variable equal to 1. In my case, I will write A is equal to 1. Now, since I have the value of A, I can now get C using this equation. So C is equal to 6A. I will substitute the value of A, which is 1, here. So 6 times 1 is 6. So 6 is A. Now I can simplify this equation by dividing 2 on both sides. So I will have D is equal to 6A. Then just substitute this value. 6 times 1, D is 6. Now in B, it's the same. Just substitute all the values that we got to this equation. So 6 times 1 plus 2B equals 2 times 6 plus 6. Now do the math and you will get B is equal to 6. Now again, these variables are your coefficient. So what I will do is to change this to the numbers I got. So I will have 1 C6H12O6 plus 6O2, 6CO2, and 6H2O. Now your equation is balanced. Take note that we don't write 1 here. Okay? Now let's check. I have 6 here and 6 here. So the carbon atoms are balanced. Now hydrogen, I have 12. I have 6 times 2, 12. So hydrogen is balanced. Oxygen, I have 6 plus 6 times 2, which is 12, 18. I have 6 times 2, 12, plus 6, 18. So we can say that the equation is balanced. Now let's have another one. So this reaction is read as aluminum reacts with oxygen, which yields aluminum oxide. First step is to assign variables A, B, and C. Then we write our equation. For Al, it's A equals 2C. For oxygen, I have 2B is equal to 3C. Now I have all the coefficients, A, B, C. I can now get the values. Let's assume A is equal to 1. We can solve for C using this equation. 2C is equal to A. Divide this by 2. We will get A halves. And A is 1. So C is equal to 1 half. Then we can now get B. 2B, this equation, is equal to 3C. B is equal to 3 halves C. And since C is 1 half, substitute this one. So B is 3/4. So our equation will be Al plus 3/4 O2 yielding 1 half aluminum oxide. Now we need to remove the fraction. So what we're going to do is to multiply this equation to the least common denominator, or LCD, which is 4. 4 So our balanced chemical equation will be 4Al reacts with 3O2, yielding 2Al2O3. So if you check, I have 4 aluminum here and 2 times 2, 4 aluminum here. I have 6, 3 times 2, oxygen. I have 2 times 3, 6 oxygen. So the chemical equation is balanced.